Welcome back. In this video we will discuss how to compute volume by using integral. Okay, so let's get started. Suppose here we have an area which is bounded by the graph of x equals 4 and the graph of x equals y squared. And then we want to rotate that area about the y-axis. Okay, so let me repeat again. We have this area bounded by the green and the orange graphs. Okay, so the method of how to set up the integral is, first we need to realize whether we have the top-bottom graph or right-left graph. In this case, there are definite left and, this should be right and left graph. So the orange one is the right graph and the green one is the left one. Okay, what does it mean? It means that our area always has a definite right bound and has a definite left bound. Okay, in that situation we slice the area along the left-right direction or top-bottom direction. In this case, because we have left-right curves, we slice along left-right direction. So for example, we have one slice is over here, so we slice horizontally here. So suppose this slice is of distance y from the origin and it has height delta y, or the width of the slice is delta y. Okay, so to understand how to compute the area, the volume of the object resulted by revolving this area around the y-axis, it is enough to understand how the volumes behave if we rotate this small rectangle along the y-axis. Okay, so first let's rotate this rectangle. Okay, so we copy that rectangle over here and we rotate that rectangle along the y-axis, and the resulted object is a donut-like shapes. Okay, so now to understand how to compute the volume of the whole thing, first we need to understand how to compute the volume of this object. Notice that this object can be think of as a cylinder minus a smaller cylinder. Okay, so let me remind you, let us recall what is the volume of a cylinder. The volume of a cylinder simply the area of the base multiplied by the height. So if the base has radius r and height h, then the volume is, so the area of the base is pi r squared multiplied by the height. So we have V equals pi r squared h. Okay, so as we discussed earlier, this object is the same as the bigger cylinder minus the smaller one inside there. Okay, let's say that the bigger cylinder has radius capital R, which we call it as the outer radius, and the smaller cylinder has radius little r. Okay, then the volume, sorry, let me copy here, the height is delta y. Then the volume of the big cylinder according to that formula of cylinder will be pi capital R squared times the height, and the height is delta y. Okay, and similarly we have similar expression, pi radius squared, but now the radius is that little r, times delta y. Or we can rewrite this as pi r squared minus little r squared delta y. Okay, imagine that we are not only have this one slice, but we have infinitely many slices. So imagine that over here we can have another slice, and then let's say over here another slice. So the idea to compute the volume is to add all of these slices. And how we can add all those slices? By integrate all of them. Okay, so before we continue to pursue that idea, first let's identify what is the outer radius. The outer radius is the distance from the axis of rotation to the end point of the slice. And the end, okay, so the outer radius will be the distance from here to there, which is 4, because the end point of the slice is on the line x equals 4. Okay, so the outer radius is 4 squared delta y. And how about the inner radius? The inner radius is the distance from the axis of rotation to another endpoint of the slice. And since the other point of the slice lies on the graph of x equals y squared, then the distance will be y squared. Okay, so here we have pi y squared delta y. Okay, so by understanding this expression, or let me use this expression instead, the simplified version. So pi, the outer radius is 4, so 4 squared, and the inner radius is y squared. So we squared y squared. We have y to the 4th delta y. Okay. So as we discussed earlier, we have objects like this starting from this point up to that point. Okay, and you can verify that the intersection points, this and that intersection point, has y coordinate equal to -2 and 2. can verify quickly because this negative 2 and 2 is the solution to 4 equals y squared. Okay, so we want to integrate this kind of objects starting from y equals negative 2 up to y equals 2. So we use the integral notation. We integrate from negative 2 to 2 of all this kind expression. So pi 4 squared minus y to the 4th dy. And this is our volume. Okay. So let me repeat again. The idea is slice the area in the direction left to right or top to bottom. It depends whether our area has definite right left or has a definite top and bottom. Okay, and then after that, try to understand how the volume looks like by rotating a rectangle. After that, we compute the volume of the resulted object when we rotate that rectangle. And then the next step is to add all of that kind of objects by using integral to get the volume that we want. Okay, let's look at the next example. On this problem, we have an area bounded above by that parabola and bounded below by the x-axis. So in this situation, we have a definite top and bottom graphs. So then we slice along that direction, that one particular slice, and this slice is of distance x from the origin. Okay. Next, we rotate this small rectangle, and the object that we get when we rotate this rectangle along, say we want to rotate along the line y equals -1. So rotate along this line. Then we have this kind of object. Where we have a hole in the middle. So basically we have a donut shaped object. Okay. Now to compute the volume of this particular object, we need to find the outer radius and the inner radius. Okay. What is the outer radius? The outer radius is exactly the distance from the axis of rotation to the far end point of the slice. Okay, so distance between those 2 points. Since the first point on the graph on the parabola and the second point on the line y equals -1, then the distance between the two will be exactly the distance between, the difference between the top and the bottom. Okay, so we have that the outer radius is exactly 4x minus x squared minus -1. Minus minus become plus. And what is the inner radius? The inner radius is the distance between the axis of rotation to the closest endpoint of our rectangle. And we can see that the distance between those 2 points is exactly 1. Okay. And now imagine that for each of this rectangle we have this object. But if we slice our area into many rectangles, then we have many this kind of object starting from x equals 0 up to x equals 4. So to get the volume of the whole thing, we need to add all of this kind of volumes starting from x equals 0 up to x equals 4. Okay, so the whole volume is equal to the integral from 0 to 4 of the expression that's similar to the volume of this object. So I forgot to write the volume here will be pi capital R squared minus little r squared delta y. Okay, so again we can do the same here, pi, but we knew that our r is that expression, so 4x minus x squared plus 1 squared minus little r squared. Little r is 1, so we have 1 squared, and then dy. And this expression will be the volume of the resulted object when we rotate this area around the line y equals -1. Okay, so for the computation, I will leave it to you because we don't have time to do the computation. If you have any question, if anything is not clear, or if you have any comments, please write down on the comment section below. Thank you for watching. See you on the next video.